Good morning, everyone. So today we are going to see the remaining 2 points from the that is from chapter one. That is compressed air energy storage and pumped energy storage. Okay. So now, as we know, uh, up to now, until now, we saw the different types of the power plant, including the hydroelectric power plant, thermal power plant, gas power plant, okay, then the nuclear power plant, etc. So, okay. So whatever the energy developed or the power developed through these power plants, it is in the form of electric energy, right? So what we actually do in this particular power plant, we just convert the energy from one form to the electricity, okay, and the electricity, as we know, it is the high grade type of energy, and we can use its application is very wide application. We can convert that electricity into the other type or other form of energy conveniently. But one of the major drawback of electricity is that we cannot store the electricity, okay, as it is. So we cannot store the electricity in the form of electricity. We have to first convert it into another form of energy, and then we can store the particular electricity or particular energy. So because of this drawback, what will happen? So whatever the energy, electrical energy we are producing in the different power plants, we have to consume it at that particular time. Okay, so we cannot store it for long period. Okay, so in that case, if there is any power plant which is producing an extra energy, okay, so in that case, that extra energy just going to be a waste. So to avoid this, we have to store that extra energy or extra electricity generated. So as we know, we cannot store it in the electrical form. So we have to convert it into the other form, and we can going to store it. It may be converted into the mechanical energy. It may be converted into any thermal energy, right, like a heat, okay, or we can convert it into the mechanical energy, right, the potential energy or kinetic energy, etc. So why necessary those storages? Okay, so these storages we are going to see that that is the pumped storage and also the compressed air storage. Okay, these storages are used to store this electricity, electricity we are developing or we are generating in the power plant in the form of potential energy of the water or in the form of compressed air. Okay, so for that we must considering this particular battery, this consider this particular point. Okay, we can also call this as one type of a battery. Like in battery, we are converting or we are going to store, we are storing mostly the electricity in the form of chemical energy. Similarly, in this particular case, we are storing the electrical energy, the excess electrical energy, in the form of potential energy of the water or in the form of compressed air. Okay, so for that, these two particular points are very important, or these two particular storages are very important. Now, we can also store the electrical energy in the form of mechanical energy, in the as we say the example of flywheel. Okay, but that storage is only for very small amount of time, a very small period of time. Okay, we cannot store beyond 10 or to 15 minutes, right? So in that case, we cannot store the electrical energy that much for large period of time. So for that, we going towards this particular pumped storage or the compressed storage. Okay, in that the first one that we are going to see, that is the pumped storage, or we can say it is one type of a battery where we store the energy. We are storing the energy. Now, why we required this one first of all? Okay, so if we generally see the any particular power plant, okay, if there is any particular power plant, it will produce some type of some energy, okay, or some power. Okay, so considering one, there is one hydroelectric power plant which is having the rating nearly 1000 megawatt. Okay, just considering 1000 megawatts it will producing, right? Now the required or the demand for this particular electricity will vary with respect to the time. Okay, means consider during the daytime, the demand is very low because the consumption of electricity is low. At the morning time and at the evening time, the electricity demand for the electricity is very high. Okay, so in that case, the variation in the demand will cause, or because of the variation in demand, we cannot consume this 1,000 megawatts which is generated inside the hydroelectric power plant continuously. So considering at the morning and at the evening, we are going to consume this 1,000 megawatts, but at afternoon or during the night time, we are not going to consume those 1,000 megawatts. Okay, so you will say that just switch off the power plant during that particular time. But the main problem is that the hydroelectric power plant and also the thermal power plant, uh, we cannot instantly switch off or switch on this particular power plant. It will take some time. Okay, it may be in hours or even in the days in the case of thermal power plant. So because of that, what will happen, we are continuously producing this 1,000 megawatt of energy. Okay, so at the night time and during the daytime, we are not using that much of energy, or we are just using 800 megawatt. Just consider we are using 800 megawatt during the daytime. Okay, and also there is a change in demand with respect to seasons, right? So during winter season, we require more electricity. During summer season, we are required more electricity, right? So this variation, because of this variation, the excess amount of electricity which is generated inside the thermal power plant or in a hydroelectric power plant, we have to store it. Okay, so as we know, the main drawback of electricity is we cannot store the electricity as it is or as in the form of electricity. We have to first convert it into the other form of electricity, right? So in the case of hydroelectric power plant, what we do, we are using the pumped storage power plant, or we can say the pumped storage. Okay, so when during the daytime or during the night time, the excessive to 200 megawatt of electrical energy, it is used to store or pump back the water from the lower reservoir to the upper reservoir. Okay, just a minute, I will let in. Okay, okay, Harshvardhan, can you hear me?
Yes, sir. Yes. You're audible.
Yes. Okay. So we are seeing the pumped storage power plant. Okay. So excessive energy which is produced inside the hydroelectric power plant, it is used to pump in the water back from lower reservoir to the upper reservoir. Okay. So what during the daytime or during the night time, the excessive electricity which is generated in the hydroelectric power plant, it is used to store this particular water at higher level. Okay, and after when the energy demand has been increased, in that case you can use this pumped storage or whatever the water we are stored at higher level to produce the energy. Okay, so that's how the pumped storage power plant work. So excessive during the daytime or during the night time when demand are low, okay, demand for electricity is low. In that case, the excessive energy which we are producing inside the hydroelectric power plant, we are using that excessive electricity to pump the water at higher level, okay, by using the pumps. And when there is a peak demand, means demand will be increases during the night, during the evening time. In that case, we will use that stored water which is stored at particular height. We are using that stored water to generate the more electricity. Okay, so that's how this pump storage power plant work. So you can see here in this diagram also, there is a upper reservoir is there, okay, and there is a lower reservoir. So at the normal condition, this particular hydroelectric power plant will producing some 1,000 megawatt. Now during the daytime, it will require, the demand is only 800 megawatt. So excessive energy, that is the 200 megawatts, we have to store this excessive electricity, right? So for that, what we do, during the daytime, we are pump back this particular water through these channels into the upper reservoir, which is at the higher level. Okay. So during the daytime, when there is a demand is less, we are pump back that particular water into the upper reservoir, okay, and we store it into the upper reservoir. When at the evening, when there is a peak demand, means demand will be increases. In that case, what we do, we just use this stored water to generate the electricity. So that's how the pump storage power plant work. Okay, so you can see this is another schematic for this particular pump storage power plant. So whatever the excess energy we are developing, we are using that excess energy, right? Because the main drawback of electricity is that we cannot store electricity in the electrical form. We have to first convert it into another form of energy, and then we can store it. So the main component of this type of power plants are this the turbine. Okay, turbine generator, or we can call it as a motor and pump. Okay, it will work as a turbine, and also it will work as a pump also. So during the daytime when demand is less, in that case it will pump back this particular water up to the higher reservoir. Okay, and during that condition, this particular turbine is working as a pump. Okay, and when there is the excess requirement is there, when demand will increases during the evening sessions, in that case we are using this particular water to produce the excess energy. So in that, during that particular condition, this one is work as a turbine. Okay, this device is work as a turbine. Okay, so that's how this pump work storage work will working. Okay, you can also see if there is a load requirement is greater than the supply, voltage and frequency will increases. If load is less than supply, voltage and frequency will decreases. So this pumped storage power plant will help to keep the balance. Okay, so when there is excess amount of load, excess amount of demand is there, in that case we are producing the power and giving or obtaining that particular excessive demand. And if there is decrement in the demand, in that case we are using that excessive energy to pump back that particular water. Okay, there are many power plants are already installed in the world. Okay, you can see during that for the year 2014, this is the different installed capacity of PSVP pumped storage power plant into the world. Japan has maximum amount of pumped storage power plants which are installed. Now, these are useful in the case where the water is not available in large quantity. Okay, so in that case, we are using this particular power plant. Okay, so this is the pumped storage power plant, and the main component is motor generator, or we can say the pump turbine casing. Okay, this one is the most important component because during the power generation, it will work as a pump and turbine, and uh, during the off conditions, or during the pumping conditions, it will work as a motor and pump. Okay, so this device is very important in this particular power plant. Okay, the details are already given. This adjustable speed pump storage, we can adjust the speed of this particular pump. I will just show you one video of this pump storage power plant, so you will understand the actual working of this particular power plant.
The Project Hydro Pump Storage System in Amphilohia is being developed by Terna Energy, a company with a strong and successful presence in the field of renewable energy sources, both in Greece and abroad. The project is located in the western Greece region, prefecture of Attila Karnania, municipality of Amphilohia, Valtos province. It is characterized as a project of common interest because of its high importance to the European energy market. Both the technical studies and the environmental impact assessment are co-financed by the Connecting Europe Facility program. The project is also considered as a strategic investment for Greece. Hydro pump storage is considered as the only low-cost and effective method of mass energy storage in the world. It is environmentally friendly and can be easily developed in areas where the topography and water reserves allow for it. In Greece, the Public Power Corporation has built and operates 2 such plants. This investment upgrades the existing infrastructure and power systems. The project's design includes the construction of 2 independent upper reservoirs, Pigos and Ayusioyos, while the existing Kastraki Lake will serve as a lower reservoir. 2 independent energy production and pumping stations will be constructed. Ayusioyos will host 4 reversible units and Pigos 2 reversible units. The system will store energy surplus during hours of reduced demand by pumping water from the lower to the upper reservoir. During peak demand, it will produce energy by utilizing the water's potential as it runs through turbines from the upper to the lower reservoir. Hydro pump storage systems safeguard the grid by providing ancillary services related to frequency and voltage stabilization alongside quick and flexible responses to sudden changes in electricity demands. Consequently, the provision of ancillary services to the grid facilitates the penetration of intermittent renewables. Hydro pump storage systems contribute to a considerable reduction of pollutants and greenhouse gases since they do not use polluting fossil fuels during operation. The areas that will host the facilities will benefit in various ways, both by the increase of visitors and the development of new and existing infrastructure. In addition, around 900 people are expected to be employed, directly and indirectly, during the construction phase, while a variety of machinery and raw materials will be utilized. During operation, local specialized and auxiliary personnel will be employed in 60 new jobs. In terms of public consultation, a series of informative events and communication activities took place to inform the local community about the project. Hydro pump storage projects, like all hydroelectric projects, have very high domestic added value and contribute significantly to the Greek economy. The project will provide flexibility and stability to the Greek electricity transmission and distribution network, as well as significant ancillary services. This investment is a crucial step towards Greece's non-independence from imported fuels and can support the country's return on the growth path.
So that is about the pumped storage type of pumped storage power plant. Okay. So similarly, another power plant is there which is used to store the energy. That is known as the compressed air energy storage. Okay. So similar to the pumped storage power plant, we are using compressed air. We are using the energy to compress the air, and we store that compressed air into one particular vessel or into the below the earth. Okay. So during the peak time, whenever we required, whenever the demand is very less during the daytime, whenever the demand for the electricity is very less, in that case, the excessive electricity is used to compress the air and store that compressed air. Okay, after the peak or during the peak time, whenever demand has been just increased, in that case, we are using that compressed air to run the extra turbine. Okay, and that will produces the electricity. So that is also very similar to the pumped storage power plant. In pumped storage power plant, we are storing the energy in the form of potential energy of the water, and here in the compressed air energy storage, we are storing the compressed air. Okay, and we are storing the electricity in this particular type of energy. So compressed air energy storage is one of another among the different storage plants. We are using flywheel, batteries, superconductors, and different storage. Even the thermal storage also we are using. This compressed air energy storage is combination between the pure storage plant and the power plant. Okay, so we are using the underground caves to store this particular compressed air. It is already installed in stall level in 1948. This type of power plants or the energy storage are available all around the world. Okay, so basic principle how it is working. So generally, the simple uh, gas turbine is there. Okay, it will having the compressor, then the combustor. Okay, again second compressor or the combustion chamber or the first turbine, and there will be second turbine. So first of all, what will happen in general working? Okay, what we do, we just take the extra air from the atmosphere, we compress it, it will pass through the combustor where combustion will take place. After that, it will pass through the different levels of the turbine. Now, whenever we using the compressed air energy storage, the change is that we first of all during the daytime when the demand is less, in that case we are using or we are taking the atmospheric air, okay, we are compressing it and we are going to store this one into the storage or the different caverns. Okay, caverns means what? It is just a storage facility. So whenever we take out the natural gas or the crude oil, that well which is remaining or whatever the space remaining inside the crust, earth crust, it is known as the cavern. So here here, what will happen? We are just compressed whenever there is less demand is there. In that case, excessive electricity is used to compress the air, and that compressed air has been stored inside the cavern. Okay, so during the time we are storing the compressed air. Whatever the excess energy developed by the other power plants is used to store the compressed air. Now, after that, what will happen at the evening when the demand has been increases? In that case, what will happen? We are using this compressed air to run the different turbines. Okay, and we will produce the extra power. So that's how we are using the energy compressed air energy storage. It is very similar to the pumped storage. In pumped storage, we are storing the or we are converting the electricity into the potential energy of the water. Here also we are using electrical energy to create or to store the compressed air. Okay, and later on whenever demand will be rises, in that case we are using this particular compressed air. Okay, so that is the simple working of this particular power plant or the energy storage. So it is work or process work by the pumping air into the vessel or cavern when the off peak demand, and when we require the energy, in that case we are using this pressurized air to create or to generate the electricity. Now, the three operations it will consist. The first one is the compression process, second one is the air storage process, and third one is the expansion process. So it is very similar to the previous one. Okay, as you already know how the compression will happen, expansion will happen. It is this particular power plant is very similar to the gas turbine power plant. Okay, so in the gas turbine power plant, we are using the flue gases, right, after combustion. Here also we are using the flue gases, but for whenever we this particular expansion of compressed air process is storage is used. In that case, we are using the compressed air which is stored inside inside the cavern. Okay, so this is the details regarding those processes. We are using the different caverns to store this energy. Okay, we can store the compressed air on the ground also or inside the ground also, but the main disadvantages of storing that particular compressed air is that the capital cost of storage is very high. Okay, and for that we are generally using the salt caverns or depleted natural gas caverns. Okay, to store the particular compressed air inside the earth crust. Okay, you can also see there are the different ways. First of all, you can also store this above the ground. For that, we require these very uh, high pressure vessels, which cost very high. Okay, which will require, which is very expensive to, first of all, the manufacturing that particular vessels are very costly. Okay, so that will cost you very high. So this is the expensive type. For to reduce the costing, we are generally use the underground storage facilities. Okay, in that case, you can use the salt caverns. Okay, or you can also use the depleted natural gas caverns, and you can also use the hard rock caverns. Okay, this particular is this particular air storage is uh, uh, very having very high capacity values. Okay, it is having some advantages, like it will reduces the CO2 emissions. It will doesn't require any fuel consumption. Okay, so these are the advantages. But the main disadvantages of this particular power storage is it is not a pure energy storage, because whenever we store the compressed air inside the earth crust into the depleted natural gas caverns, it sometimes it will get contaminated. Okay, it will came in contact with the contaminated water. It will came in contact with the different wastage. Okay, and whenever we uses that compressed air, and after that we just release it into the atmosphere, it will cause the pollution. So that is the main disadvantages. Also, the capital cost of that particular power plant or this storage power plant is very high. Okay, if you want to store this particular energy on the ground or above the ground, in that case we have to manufacture the different pressure vessels. And as we know, the costing of pressure vessel is very high. Okay, so these are some disadvantages. But with respect to different mechanical energy storage, thermal energy storage, or we can say the chemical energy storage, those are batteries, we can also use this type of storage in the large scale. Okay, the scale of these particular power plants are very large, and those are operated in world at different particular conditions. Okay, so again I will show you some video regarding the compressed air power plant, so you will get the idea regarding it.
Compressed air energy storage. This brief animation is an overview of a concept for energy storage in the form of compressed air. This diagram represents a typical case configuration plant with all necessary components. First, let's take a look at the charging process. During the periods of low power demand, the surplus electricity drives a reversible motor generator unit to run a chain of compressors for injecting air into a storage vessel. For large-scale systems, a high-capacity underground salt cavern is used. The energy is stored in the form of high-pressure air, with the pressure typically 40 to 80 bar. For small-scale systems, an overground air tank can be used. The compression process normally uses intercoolers and aftercoolers to reduce the working temperature of the injected air, thus improving the compression efficiency and minimizing thermal stress on the system component walls. The pressure of compressed air in overground tank is up to 300 bar. Now let's take a look at the discharging process. When the power generation cannot meet the load demand, the stored compressed air is released and heated by a heat source, which can be the heat generated from the combustion of fossil fuel, or the heat recovered from the compression process. The compressed air energy is finally captured by the turbines. The waste heat from the system exhaust can be recycled by a recuperator unit. The same process takes place in the case of overground air tank discharge. The high-price electricity generated can be sold to the grid.
So that is the working of this particular compressed air power plant. Okay, it's similar, or it is we are using the gas power plant for this particular conditions, or for this particular storage. Okay, First of all, these compressors will run on the excessive power which is coming from the grid or coming from any particular power plant. And this compressed air, in that during that particular time, this compressed air will compress the air and store it into the cavern or any particular underground air tank or overground air tank. When the demand will be peak, means demand will rises during the night, during the evening time or during the morning time. In that case, this compressed air is used to provide or provided to the compressor, provided to the combustion chamber, and then the remaining process will happen. This remaining process is similar to the gas turbine. In that case, we are not running these particular compressors to get the compressed air. We are using the stored compressed air. Okay, so that's how these particular power plants are used or the storages are used. Okay, so that's the conclusion of our particular first chapter. Okay, so till now we saw the different types of the power plants. Okay, first of all, the different energies through which we are generating the power in India, different institutions like the NTPC, NHPC, and their role in the power generation or power development in India. Then the power generation in private sector, then the Indian electricity grid code, present power position of India. Okay, how much power will be generated through the renewable energy resources, non-renewable energy resources, hydraulic energy, etc. Then we saw the different types of the power plants, and lastly we saw this particular pumped storage and compressed air storage power plants and their characteristics or their working. Okay, so that is the end of our first chapter, that is resource and development of power in India. It is a basic chapter. Okay, the questions come into the exam. It is also going to be a basics questions that will consisting to explain the construction and working, then giving the characteristics of any particular power plant, give the uh, give the advantages and disadvantages of the particular power plant. That will be the questions into the exams. Okay, so yeah, function of overground tank. Overground tank means it is just a pressure vessel, okay, which is used to store the compressed air. Okay, as you saw in case of compressor, reciprocating type of compressor, you will saw one receiver. Okay, receiver means it is just a pressure vessel which will store the compressed air. That is known as the overground tank. Overground tank means the tank which is situated on the ground. It is not inside crust or inside the ground. Okay, so the function of overground tank is to hold, or we can say to store the compressed air. That's it. Okay, and it will provide the compressed air whenever required. That's it. That is the function of overground tank. So any other question related to the first chapter? It is a basic chapter. Okay, there will be no any. I think there will be no any doubt regarding this particular chapter, because you already study all the power plant, the working of the power plants, detailed working of power plant particularly. We have to focus only on the this particular power generation in the India. Okay, how much power coming from the renewables, how much power coming from the non-renewables. Okay, different institutions like the NTPC, NHPC, their roles and responsibilities, their objectives and functions, that you have to concentrate on. Also, the Indian electricity grid code, that also you have to concentrate on. I will share these PPTs later on Moodle also, and on your our WhatsApp group also. Don't worry. And I also share the previous year question paper, so you will understand how, or you will get the idea regarding the questions. Okay. Okay. So can we stop here?